morning, students. Now we are going to see what are monosaccharides and examples for monosaccharides and types of monosaccharides. Monosaccharides are the simplest carbohydrates which cannot be hydrolyzed into a simpler form, that is, they do not undergo hydrolysis in the presence of acid or any catalyst or enzyme. In general, monosaccharides consist of 3 to 6 carbon atoms typically, and the carbonyl group, it may be an aldehyde or a keto group, and several hydroxy groups. The general formula of monosaccharides are CH2O n times, where n is greater than or equal to 3. Classification of monosaccharides, that is, in the carbonyl group, if aldehyde group is present along with the hydroxyl groups, then they are said to be aldoses. If the carbonyl group is a keto group and also it has got many hydroxyl groups, means that type of monosaccharides are said to be ketoses. That is, aldoses are defined as monosaccharides with an aldehyde group and many hydroxyl group. Depending upon the number of carbon atoms present in aldoses, they can be called as trioses if 3 carbon atoms are present, tetroses if 4 carbon atoms are present, and pentoses means 5 carbon atoms are present, and hexoses 6 carbon atoms are present. Say for example, in the given example, erythrose, it has got 4 carbon atoms totally, therefore tetrose. Since it has got aldehyde group, it is a aldose, that is aldotetrose. Therefore, erythrose is an example for an aldotetrose. Ketoses are monosaccharides with a ketone group. A keto group is present, C double bond O group, and it has got many hydroxyl groups like aldoses. Here also, depending upon the total number of carbon atoms present, we can classify them as a triose if 3 carbon atoms are present, tetrose if 4 carbon atoms are present, and pentose if 5 carbon atoms are present, and hexose means 6 carbon atoms are present. Say for example, in the given example, there are 6 carbon atoms present. Okay, therefore, and the keto group is present, therefore it is an example for ketohexose, fructose. Examples for monosaccharides: if number of carbon atoms 3, in general triose. If aldehyde group is present, then that is aldose, and if keto group is present, ketose. Example for aldotriose is glyceraldehyde. Aldoketose is dihydroxyacetone. Tetrose means erythrose, and for ketose, erythrulose. Pentoses for aldoses, one of the examples is ribose, and for ketose, aldoketose, one of the examples is ribulose. Finally, for hexoses, aldohexose, one of the examples is glucose, and aldoketose is fructose. Structure example, triose, glyceraldehyde, and the configuration is D configuration, and for ketotriose, dihydroxyacetone. Aldotetrose, example D erythrose, and for ketotetrose, D erythrulose. The configuration, how to give the notation D or L for aldoses and ketoses, we have to write the Fischer projection formula, and in the Fischer projection, the OH group on the chiral carbon farthest from the carbonyl group determines whether the given monosaccharide is L isomer or D isomer. And if the hydroxyl group is present in the left hand side, then that is said to be a L isomer, capital L. If the hydroxyl group is present on the right hand side, then that is said to be a D isomer. Say for example, in the glyceraldehyde, we have got only one chiral carbon atom, that if OH is present on the left hand side, therefore that is said to be L glyceraldehyde, and OH is present on the right hand side, D glyceraldehyde. Examples for aldoses. Some of the examples for aldotriose, D-glyceraldehyde and L-glyceraldehyde. Okay, there is the L isomer is just the mirror image of the D isomer. In the chiral carbon atom, what we can say, if you want to write the structure of L isomer from D isomer, just the atoms which are present in the left hand side is shifted to right hand side and vice versa. Similarly, another example for aldotetrose is D-erythrose. Then the L isomer structure can be written here. Here we have to change the configuration. Okay, what happens now? L isomer, the carbon, chiral carbon which is farthest far away from the carbonyl group, we have to see. By looking at that configuration, we have to give the nomenclature whether it is a D isomer or L isomer. Similarly for pentoses, one of the examples is D ribose, and L ribose, just the mirror image we can write. Similarly for aldohexose, D glucose, and the L glucose, just it's a mirror image of the D form. Hope you might have understood what are monosaccharides and examples for aldoses and ketoses. Okay. Thank you.